it is very much important not only in our pharmaceutical industry where we are putting crores of worth of equipment, and it is also good in our daily life where we are utilizing our vehicles and our building materials, where we are completely finding the rusting of the metals what we are using. So this is a daily phenomena and every individual is facing. That is the reason it makes this particular topic very important. So we need to learn it with carefully and be motivated to accept this particular concept so that you are going to face the question in the examination in a better manner. If you see the definition of it, corrosion is defined as the reaction of the metallic material. I am mentioning here metallic material for the sake and to bear the better understanding. Don't think that it is only restricted to the metals only. It is having a problem with the non-metals like a plastic and rubber and other materials also. This problem will be there. But the nomenclature and terminology may be utilized in a different manner, like erosion, or it may be a friction which is caused by the heat generation and getting chipping. Anything which you are going to have it the problem there, or it may be a swelling or it may be a melting. So in those cases also we are going to lose that particular material. But in this particular theory concept we are talking about the metallic material, so that your concepts will be very clear and restricted to this. And what is happening to that metallic material? It's interaction with the environment which causes the measurable change to the material. So what is having that material is interacting with environment. Environment is carrying most of the times around us we are having an invisible gas. So that invisible gas containing mixture of active and inert gases. Like you may be having a carbon dioxide, it may be having moisture that is in the form of humidity, you may be having inert gases like a nitrogen. So these are all present in addition to your oxygen, a vital element for our breathing, and it will be bound to be present. So in our factory and our rooms and working environment and offices and classroom, everywhere it will be present. So you cannot restrict it. You may be thinking that oxidation is the problem with oxygen, I can remove it and I will make the oxygen free environment. Not possible. It means that whatever the metallic material or equipment we are using, it bound to be exposed to the environment. We cannot restrict it. At the most, we have already seen in the previous video that we can restrict our humidity to the lower level or desired level, but not the oxygen removal and completely making nitrogen. This is only possible in the case where you are using a closure and you have got a container, or it may be equipment internal meniscus above the meniscus you may be filling with inert, so that you will having advantage. But we cannot make the environment of the room deprived of these gases and the environment where it is present. Because of that reason, it bound to produce some measurable change in the material. What is this measurable change means? You can view it and perceive it and touch it. So this is actually what you can measure. It means we call it as a significant. The significant change, generally we are calling every unit operation is the one which is causing a significant change in the energy or the mass. So the significant change to the material, what will happen to that? It will result in a functional failure of what? One is metallic component, that particular part, or complete system. It means the part, not only the part, entire equipment is going to get spoiled. It may be your bike, it may be your car, or anything. If you are keeping untouched for longer period of the time, the environment, which is not only containing invisible gases, it is also containing visible dust and fumes, and these are all the things which you are going to affect that and makes the measurable change. The measurable change may be it may be a smooth one, it will become a rough. The painted one, it may become rusted, and previously it is appearing as completely intact. It may be getting swollen. Sometimes you may be getting holes in it. Sometimes you have in the pin picks in that. So many changes which you can see, perceive it, and it will happen. What will happen to that particular part if it is visible like that? It will be appearing as you are having that particular part which is making you to appearing as that the functionality and the look may be going and the complete system may be getting spoiled. This is the what we are going to see it as a critical, and it is important. Now let me go to our presentation, and here we have already seen the definition. We are going to the next part, is called as a terminology of what we are going to have in the corrosion. In the corrosion, we have got the starting product is getting corroded. The starting product is normal and it is existing in complete manner and without any problem in the functionality. But it is getting corroded, and to get a corrosion product and in corrosion media. In this particular case, our metal is getting corroded, leading to a rust like a corrosion product. In the corrosion media, like an environment of your humidity, oxygen, and carbon dioxide, like that. It is very important for your exam point of view. The metallic surface undergoes an electrochemical reaction with moisture and oxygen in the atmosphere. It is the moisture and oxygen is critically mentioned here because the damage caused by them is more than remaining. Even carbon dioxide will also get affecting your material, because we know that carbon dioxide, when mixed with water, it forms carbonic acid. Carbonic acid is acidic in nature. It will undergo corrosive effect, any surface. It means in the environment where too much of carbon dioxide is also not good. So many problems will be there, along with the dust also. It may be with the fumes of your environment, where in the factory working, fumes which is getting liberated, which may also cause the damage to the equipment. Preferably, these are all present, we cannot restrict them. This moisture and oxygen, they are going to damage our equipment because they are present in the atmosphere. So this is actually called as a electrochemical theory of the corrosion. And there is another theory also present, that is a physicochemical theory. In the electrochemical theory, you have got flow of electrons and combined with changes in the chemistry of that particular metal. In the second thing, you are changing in the physical, like characteristics like your shape and size, smoothness, and its softness. Everything will be changed. It may be going to melting also. Sometime it is getting sublimed. Sometime it may be going to vapor state. So these physical changes will occur, may or may not resulting into chemical changes in the physicochemical theory of the corrosion. Most preferably, physicochemical theory is most applicable to the plastics and rubber and non-metals, because they tend to get swollen, they may be getting deformed or getting eroded or shrinked. So this problem will be present in them. Sometimes they may be getting melted. Maybe you are finding with your plastics, or it may be leached. Some of the plasticizers in the plastic may be getting leached. So you find the corrosive effect may be related to the cancer, because of the carcinogens they are liberating in the hot atmosphere from the plastic. It is going to cause the health hazards because they are carcinogens. So in this particular approaches, when you see the electrochemical theory is more causing a damage when compared to remaining, because that we can restrict by preventing the such environmental damage by putting a barriers or a coverage or a package or a protection or coating. Such things we can prevent it. But the most problem in this electrochemical theory, because the mechanism involves the formation of anodic and cathodic areas, and it is also called as galvanic corrosion. It means both the electrochemical theory of the corrosion or galvanic theory of corrosion, both are same and they are synonyms. So in the galvanic cell also, we are having, there is a chemical reaction is taking place and liberating the electrons, and flow of electrons are taking place from anode to cathode. So this theory is applicable for any metals where we are having a dipped into an environment where it is containing some acidic in nature. So electrolysis will be taking place and one of the metal is getting dissolved. So this phenomena you may be already remembering in the intermediate cases, where you have got two electrodes, one is anode and there is a cathode. So this phenomena is a galvanic cell, you know it. In the galvanic theory of the corrosion, in the similar manner, you have got one material is acting as anode, another metal is acting as a cathode. And the cell is completed by having a connection and putting in an environment where it is going to have a chemical reaction progression. Generally, more active metal, that is actually weakest metal and more active, that will be acting as an anode and it will be getting dissolved. And Cathode is, when compared to remaining two series, one is having more active, another one is less active or inert. That inert will be stable and it is not going to be undergoing corrosion. So that will act as a cathode. So the generally more active metal is acting as a anode, and anode is the area corrosion occurs preferably. That is the reason we are going to study these theories and implement some of the prevention approaches so that our equipment is going to be getting protected. If you see the galvanic theory, it is also electrochemical theory. It is depicted in this particular slide. It is containing two electrodes. One is zinc, another one is copper. So the zinc electrode is having a metallic zinc where it is not having any charge initially when the corrosion is not taking place. But when the corrosion is getting started, the zinc which is inert, which is not having any charge, which is presented and named in the left side of this particular diagram, undergoes the oxidation and liberates electrons, and it causes the formation of Zn2 plus, that is having a two charged species in that particular metal. So Zn2 plus is getting liberated and two electrons are liberated. They are going to travel to the other side of the metal, which is present as a copper, that is acting as a cathode. Cathode in this particular reaction, it gets reduced by taking these electrons and combining with hydrogen ions which are present in the environment, that is H plus ions, to get a hydrogen gas. So this hydrogen gas is again charged, charge is not there, H2, it will become H2 without any charge. By taking H plus, two H plus ion getting connected with two H plus ions are getting interacted with electrons and they will be forming as hydrogen gas. So this hydrogen gas will be appear as a bubble on the particular metal. So the bubble will be initially a microscopic in nature and they will become tend to bigger and bigger when the reaction is progressing, and the bubble appears as a bigger, and because of its lighter in weight, and it will tend to float to the meniscus and it will enter into the environment. And that particular area is again deprived of this hydrogen layer. Again, they will be having a contact with H plus ions and the reaction of electrons with H plus is progressing it. When the electrons are getting depleted, always the anode keeps on getting degraded and converting into Zn2 plus, and the reaction is progressing it. And meanwhile, the zinc is metal is getting dissolved slowly by the formation of zinc chloride as a corrosion product. In this environment, what you are seeing is a corrosion media is electrolyte HCl solution, where you have got acidity and zinc is getting corroded, and the corrosion product which is formed is zinc chloride in this particular reaction. So this is actually called as a galvanic theory and electrochemical theory of a corrosion, and you are going to get it as a 5 marks question or 10 marks question, or it may be split into A and B. Sometimes they are giving C also and asking you to A, define corrosion, write the theory of corrosion, and they may be asking in the C, factors affecting corrosion or prevention of corrosion. So this is actually the pattern. We are in the midway now and we will go to a single metal corrosion. In this particular diagram, what we are viewing is two metals. These two metals are getting formation of a galvanic cell and it is getting degraded. And a particular point of time, all the zinc which is present exposed in this particular setup is getting dissolved and corrosion will be stopped. You may be thinking that, is it possible to prevent the corrosion by using a single metal without having two metals? In that particular problem is that one metal is weak, another metal is a more inactive, and another metal is active. So active metal is getting degraded. So if I use it only single metal, I can prevent the damage. But the case is not like that. It is going to get affecting your single metal also by the theory which we are going to see now. In the theory of single metal corrosion, the corrosion reaction is taking place. If you see here, the entire is an iron piece. This is made up of iron only. This iron piece has got a groove, or it has got a curve in it, and one part is exposed to the more corrosive environment, another part is exposed to the less corrosion environment. The media effects are very less. So the less prone to get the corrosion, where you have got a exposure very lesser. So that will act as a cathode. The remaining portion, which is exposed to the more corrosive environment, will act as an anode. Even in the single metal also, you are getting a galvanic effect, and anodic side of that particular single metal getting be eroded and dissolved, and it will become weaker and weaker. This phenomena even observed in the single metal also, because there is a deviation of its exposure and making that particular part more and more getting damaged. So in this particular case, your metallic iron, which is converting into Fe2 plus, and Fe2 plus, which is liberating 2 electrons. These 2 electrons are getting interacted with H plus ions, and these H plus ions taking 2 electrons, converting into hydrogen gas. The hydrogen gas is getting liberated into the environment and making it the corrosion progression. In this case also, anodic side, you have got an oxidation, and in the cathode side you have got a reduction. So that is making it to progression of the reaction completely going on, and makes the corrosion is broadly divided into the 2 types. One is dry corrosion, another one is wet corrosion. So the name itself, it is indicating that in the wet corrosion you have got a solvent effect, preferably water, and in the dry corrosion you don't involve any water. So this is actually the major difference between these two. So in the dry corrosion, it involves direct chemical attack of atmospheric gases like carbon dioxide, oxygen, H2S, and sulfur dioxide. These are all carbon dioxide, oxygen, that is, sorry, sulfur dioxide, and you have got halogens like chlorine, bromine, iodine, fluorine. So these halogens and inorganic acid like sulfuric acid, hydrochloric acid, nitric acid, these acids, inorganic acids, these vapors, they will be getting affected, affecting this metal and making it degradation, progressing it. It is actually a chemical attack of all these corrosive gases. And oxygen is the one which causes the oxidation and make the progression by liberating the electrons, and electrochemical theory dominating with the oxidation. So this is actually what you are finding in the dry corrosion. The second one is wet corrosion. It occurs due to the setting up of large number of tiny galvanic cells in the metals. So many cells in the presence of impurity as well in the presence of moisture. Most of the times, your mother or father may be making the car or by cleaned in regular manner by mopping it and removing the surface dust. You may be observing it, why they are doing it. It is not that for seeing better look like that. It also enhances the life of the particular that is vehicle. Reason is that if the dust is present on the particular surface, it will provide a great opportunity to get attacked by the moisture, and the moisture is also getting present there. It will form as a corrosion progression. It will provide in those areas where the dust is present. That is the reason, in order to prevent this is happening, so we are going to avoid the dusting by mopping it regularly on the equipment surface. The same phenomena we are going to apply in pharmaceutical industries also. When we are not using any equipment, even though it is having a status of cleaned, but we ensure that it is completely covered with a cover that prevents the formation of and accumulation of the dust onto the surface, equipment surface. Generally, every equipment in pharmaceutical industry, after the cleaning, it will be given as a named cleaned, and the name mode will be present. The log will be logbook will be showing it's when it got cleaned, and it is covered with completely to prevent the external environmental exposure. This is actually what we are preventing the rusting and because accumulation of the dust onto the equipment where we are not using for maybe days, weeks, or months. Depending upon our batch or demand, we may not be using it. So this is actually what the problem with the wet corrosion. It occurs due to setting up a large number of tiny galvanic cells in the metals in the presence of impurity as well as in the presence of moisture. Example, rusting of iron in the moist atmosphere is one thing which you can link it to it. Now, we are going further and seeing further types of the corrosion. It is very much important stating that simply writing a wet corrosion and dry corrosion and naming it and classifying and not possible to get 2 marks if it is been given as a type of corrosion. But it has been given as a define and mention the types. Definition 1 marks and types you are going to write 2 marks in the previous slide, that is going to be sufficient. But if you have been asked the types of corrosion only and you are writing simply wet corrosion and dry corrosion, it may not be able to fetch you 2 marks. You need to further expanding your wet corrosion, further divide into the 4 types. So in the wet corrosion, the fluid corrosion, you have got 4 types. You see here you are finding one is general, another one is localized, another one is a structural, another one is biological. General, localized, structural and biological corrosion are coming under the fluid corrosion or the wet corrosion. So in the general corrosion, you have got in these 4 heads. In the second category, localized is further having classified into another 4 categories like localized corrosion, which is site specific and stress induced, liquid flow related and chemical reaction related. So these 4 categories of the localized corrosion again further divided into the subtypes. Each one which have got subtypes, and if you see here, each subtype has got subtype of classification. It means you are having a hierarchy of your classification going it. If you have been asked for 5 marks question, you need to write all this entire classification with mandatory without any skipping. If you have been asked definition and small types mentioning it, just you mention it, it is sufficient. If you have got a 2 marks question only for types, you classify broader categories and mention it all, name it. If it is been given as a 10 marks question, then you need to classify the entire thing and explain all the things briefly so that you will be able to get all 10 marks. So this is the way you are going to have each question getting answered in the examination depending upon the weightage of the marks which have been given in that particular question paper. The same question may be given in the 2 marks question or 5 marks question or 10 marks question. You may be feeling difficult to expand your answer. Sometimes you are going to have difficulty to shrink your answer to the lower level. So this type of art of attempting your question paper, you need to have a mind of a preparation and making it attempt in a proper manner so that you will be having better gaining marks. In the general corrosion, you have already discussed in the previous theories. One is a physico-chemical theory and electrochemical theory. This is generally happening in almost all corrosion processes. It is a general phenomena. We are broadly categorized them. So this is actually what the classification is: physico-chemical, electrochemical. In the electrochemical, we have seen involvement of electricity flow and galvanic theory, where you have got 2 electrons, one is anode and cathode. Anode is getting corroded. In the physico-chemical theory, one component may be getting melted and one component may be getting eroded, or it may be swollen, or it may be deformed. So this physico-chemical theory is also going to damage your plant part. This is actually a general corrosion, which we have already seen. A localized corrosion we will be discussing a little bit later. And let me go to structural corrosion. In the structural corrosion, the structure of the metal or the material of plant construction is getting undergoing. It is getting altered. Most of the times you have got a carbon steel, stainless steel alloy. In those cases, you have got a carbon with various levels of concentrations. When you are exposing to the higher levels of the temperatures in the reaction mixture, so the carbon is getting tendency to convert it into graphite. Graphite is also a carbon, and at higher temperature they will be formed. So this graphite is fragile in nature. It will be getting entering into the reaction mixture. So this graphite corrosion will be happening because of the odd atmospheres and environmental condition where we are putting our reaction in our pharmaceutical industry. There they are carbon which is present as mixed in the metal of metal structure getting separated as a graphite and it is removed from the surface, and it causes the weakening of your metal and damage. It may cause the deformity and leaking, and further removal of that particular part is mandated. The second approach in the structural corrosion is dezincification. In the dezincification, we have got so many metals with the alloys of zinc. So copper with the alloy zinc, you may be getting brass. So you may be getting different alloys, and in that you are adding this component. This is actually preferably a active metal, so it can act getting removed by sorry, it is getting removed by the environment, and the material of alloy get dezincified, and zinc is depleted from that particular surface. It may become rough and weak. So this is actually concept of a dezincification. And the fourth one, what you are seeing in this particular screen, is biological corrosion. In the biological corrosion, there is an involvement of microorganisms. So there are so many varieties of microorganisms which can survive in the soil and deep sea, and wherever the odd environment, some are growing even in the absence of the air also, like your anaerobic organisms. So these organisms, they have got the tendency to grow in the odd environments also, and sometimes they may convert one chemical to another chemical also. Generally what they do, they convert sulfates. They are generally inert and they will be present as less active and not non-reactive material, and these microorganisms convert them into sulfites. These sulfites are more reactive, and they will be exposed to the equipment surfaces. They get to interact with the metal and forms the metallic sulfides and getting dissolved. By dissolution of that particular metal, you are going to have problem in that particular surface, and you are going to have a roughness initially. After that, it will be getting deepened further, and it will provide the opportunity to grow in the grooves of that particular rough surface and makes the further corrosion progressing it. So this is actually what the problem in the microbiological attack of the attack, converting a less active components into more active components, and making that more active component attacking your material of construction and breaking your material, and